Okay, so we're going to talk about problem number 4 right now, and I'm going to assume that you are comfortable enough with differential, like implicit differentiation, that you can do part A on your own. So I'm going to leave that one for you to do. And then on part C, we haven't really talked about the second part of that question. We will shortly, but I'm going to mark that part out, and we'll talk about that when we come to it. So let's start with part B. We want to show that there's a point with x-coordinate 3, which the line tangent to the curve is horizontal. So first of all, if we have a horizontal line, that means the slope is 0, right? So that means that dy dx would have to equal 0. So 3y minus 2x over 8y minus 3x would equal 0. Multiply both sides by the denominator, so 3y minus 2x would equal 0. So that means basically that y would equal 2/3 x. Now this is a relationship that's implied by the slope being 0. But remember we talked about in class, when a line is tangent to a curve, it also has to touch the curve. So it has to satisfy the curve itself. So then what I'm going to do is take this relationship between x and y and this relationship between x and y and treat them like a system of equations. So I'm going to replace all the y's in my original with this y equals 2/3 x that I got from making my slope 0. And now I'm going to start multiplying stuff out and solving for x. So let's see. We got x squared. When I square 2/3 x, that would be 4/9 x. So this would be 16/9 x squared equals 7. And this would be 2x squared when I multiply it out. So I'm going to combine the x squared terms. So that would give me 7/9 x squared equals 7. Multiply both sides by 9/7, I get x squared equals 9. So x could be positive or negative 3. So what I've proven right there is that there is a point with x coordinate of 3. The negative 3 is there too, but the 3 I've proven actually has a horizontal slope. And then they want me to find the y coordinate of p. So remember we talked about you have two relationships between x and y here. It's this one and this one. You want to use the simpler one. So I'm going to take the 3 that we proved and I'm going to say, hey, y is 2/3 of 3. So it's 3 comma 2. All right, so I'm going to do part B after I clear the screen. All right, so let's talk about part C, which is finding the second derivative. So again, I'm going to find the derivative of the first, and that will give me the second derivative. So my goal here is to take the derivative of this thing, and it's implicit, so I'm going to replace it with the Newton notation before I start. Now, I could do this with the quotient rule, or I can rewrite it as a product. It doesn't really matter to me. I'm just going to do the quotient rule. So, the second derivative is low d high, that's the constant multiple rule and the power rule, minus high d low, constant multiple rule, the power rule, all over low. Now, they asked us to find this value at the point you found in part B, which if you remember, it was 3 comma 2. So what we're going to do is everywhere we see a y, we're going to replace it with 2. Now remember, in this case, the f of x's are y's. So I'm going to have 8 times 2 minus 3 times 3, because that's the x value, times 3 dy dx, I'm going to have to come back to that in a second, minus 2, minus 3 times the y value, minus 2 times the x value, times 8 dy dx, and again we'll come back to that in a minute, minus 3, all over 8 times 2, minus 3 times 2, squared. Alright, so a couple of things here. First of all, this part right here is 0. So this whole thing on the end is just going to go away. So really all we need now to finish this is we've got 16 minus 9, which is 7, times 3 times dy dx minus 2, which we need to talk about, over 16 minus 6, which is 10 squared, which is 100. So now I need to figure out what 3 times dy dx minus 2 is. So if I come back up here to the dy dx, and I plug in the point that we're doing, which is 3 comma 2, that will give me 3 times 2 minus 2 times 3. And I think we did this in an earlier part of the problem, right? But just, making sure. 8 times 2 minus 3 times 3. That gives you 0 over a number, so that's 0. So essentially dy dx then is 0. So it's going to be 0 times 3, 0, times negative 2. So 0 minus 2. So that's going to be a negative 2 there. So basically what you get is negative 14 over 100, which is negative 7 over 50.